the SAT only covers the basics of like every topic. So for trigonometry, they're also just going to cover the basics. They're not really going to go into much detail, so you won't need to have many formulas memorized because there are many other formulas. But the main ones you need to know are like what sine is, like know the sine, like sine of A would be the opposite side over the hypotenuse. The cosine of that angle would be the adjacent side over the hypotenuse, and then tan of that angle would just be the opposite side over the adjacent side. Those are like the three main ideas. If you see like sine, cosine, or tangent on the SAT, just know that it's going to be covering like that stuff. And just memorize those. And then the other important thing is just because of the Pythagorean theorem, we have that sine squared plus cosine squared is 1, which is right here. So the main one on this side is just to know that sine squared plus cosine squared is 1, and you probably need to use those equations to solve like one of the SAT problems, but they're not going to go into as much detail. Oh, and you also need to know that the cofunctions. So these are if we have this angle A, and we know that sine of A equals one thing. So we know that sine of A is equal to this BD over this AB. We also know that sine of this angle B over here would be also sine of 90 minus A, and well, cosine of this angle B over here would be the same as sine of A. So over here, we would have our equation. So sine of A is also equal to cosine, cosine of 90 minus A. So those are like the three main equations you need to know, and then they'll just give you problems testing like variations of all of those equations and make you try to solve it. Okay, does anybody have any other questions? Okay, if nobody has any questions, do you want to suggest topics that you think you want more review on? Because we can go over the algebra stuff, or we can go more over like the data and analysis. Okay, word problems with charts. Okay, so like charts like the histogram and the box plot, you mean? Okay. I will try to find some of those. Okay, so I will go on to our SAT math books in the Google Drive. If you want to go on with me, you can see the same problems, or I can actually just share the screen. Okay, I will do that. Okay. So if you open up our SAT Math, the 16 complete tests. Okay. It is taking it's taking me some time to pull it up, so. Okay, so this book is very helpful. It has many like tips. It's not loading yet, but it has many tips and it has many problems for you to do related to those tips. And then at the end, they have like the complete answers and an explanation of those answers. But we can do one of the practice tests and go through it. If it loads. Okay, let me reload the page again. Okay. It's very slow. We can, okay. I don't know what to do about this. Okay, let's just wait a little bit more. Okay, maybe if I stop the share, I don't know if maybe I stop my video. Is it okay if like I stop my video so that I can have like better connection? Okay, I'll just stop it. It should load better now. Okay, I will. Okay, it has loaded. Okay. Okay, so we have our contents, but we're going to go all the way down to our first practice test. Which should be somewhere around these pages. Okay, see, these are like the tips and their answers. Okay. So the problems about data analysis and these graphs are not going to be on the no calculator section, okay? Because those are all on the calculator sections. So always go on to the section 4 because that's the calculator section. Okay, maybe I can turn on my video again. Okay. So these are the formulas you are provided. You only know these references to like the area of triangles or rectangles or circles, and then you also know these volume formulas. And then they also just give you like really basic knowledge, like the number of degrees in a circle is 360 degrees, and there are 2 pi radians in a circle, and then the sum of the angles in a triangle are 180 degrees. So you would not know the trig functions. Okay, so okay, so you want word problems with charts. So we can try number 8. I'll give you like some minutes to read the problem, try the answer, and I will do it along with you. If you have the answer, you can chat. Okay, so far I got one answer. Does anybody else have an answer? Okay, we can go over this one. Okay, so this problem with a chart, this is like what we talked about before, what we talked about yesterday actually. This is a very common graph, and we talked about like the basic method for solving this type of graph and like this type of question. So we have these 20 students. Always look in the title for like the number of things there are, the number of things you're measuring. So if you're trying to find the arithmetic mean, so this is the mean, this is the most common kind of average that you see, you sum all the values up and divide it by like the number of values there are. So we already know that there are 20 values, so we're going to divide it over 20. Okay, and then for each of these, for 2 students, they got a score of 30. So we have 2 30s. Okay, so we have 2 times 30. And then we have to add. Okay, so now we look at 4 students. These 4 students all got 70s. So we have 4 times 70 because there are 4 70s. Okay, and then we have 6 students, and so there are 6 100s. So 6 times 100, I'll just have 600 because I'm kind of running out of room. And then we have 5 80s, so there's 400. Okay, and I'll write the last one above. We have 3 40s, so you have to add 120. So if we add up all of these, in the end, if you calculate it, you should have gotten 1460 over 20. And this is just equal to 73. And this gets our answer of B. Okay, so you can check your answer. Okay. Let's look at another data analysis one. A lot of these are geometry. Okay, here is one. Okay, I'll give you a few minutes to look over it yourself. And yes, I will do that afterwards. Okay, so I'll give you a few minutes to do this, and you can text me in the chat your answer afterwards. Okay, so yes, this one is basically just kind of interpreting the graph, and you see a line of best fit. This is called the line of best fit because these points are the closest to that line, basically. If you draw any other line, they would not be as close to that line. Okay, so it's kind of calculated by standard deviation. But this is our line of best fit, so we're basically just using our line of best fit to find the closest average speed that these taxi drivers are driving. So we have that if we have our line of best fit, we see that there's an intersection here and there's an intersection here. So we have that they basically drove 480 miles over 8 hours. So this is 60. Our closest answer to 60 over here would be B. So that would be 59. Okay. Do you understand? Okay, so I just got another request to go over number 11 on the Google form. Do you want to do that? Okay, I can just pull up the Google form real quick. Thank you. Okay. Oh, oh my gosh. Okay, I don't know if I actually have the Google form answers, but am I correct that you guys did 2020-03? Like the test name. Okay. I will pull that up. Okay. Oh, yes. Okay, was it one of the ones that I went over? Which 11 was it? Because I know there were two 11s. The first one was on, okay, the first one was on the no calculator section. Okay, it is loading. Oh, it's this one. Okay. So this one is about circles. I actually did not go over equations of circles with you. I can actually do that really fast. Okay, so an equation of a circle, because it's not like a linear function, or it's like also not a polynomial or an exponential function. It's a different like equation. It's not loading, but we have, let me see if I can share a whiteboard. Maybe that would be easier. Okay, can you see this whiteboard? Okay. So our equation of a circle, we have both of the x values and y values on the same side. So it is x minus x1 squared plus y minus y1 squared is our radius squared. So just know that r stands for the radius, and the x and the y are the actual variables. The x1 and the y1 are the coordinates of the center. So the center of the circle would lie on x1 comma y1. And then after we know like a center of the circle and we have our radius, we can draw a circle. So that would be our circle. So in our problem, it was something like x plus, I forgot exactly what the number was, but we only need the y value basically. So I'm pretty sure it was y plus 12 squared. That was our y part of the equation. Okay, and this equals like 49. So if we know this equation, we know that the center would be at the coordinates that x1, that I don't know exactly what it is, comma negative 12. Because this part is actually adding it, so it's subtracting a negative number. From our general form, it's always going to be subtracting. Okay. Our general form has y minus y1 squared. So that means that the center is going to be at some x value, comma negative 12. And since we want to shift this circle up too, that means we're shifting all the points on the circle or inside the circle up by 2. So that means our center should be at x1 comma negative 12 plus 2, which is negative 10. So we're basically shifting it like that. Okay, and so now we can construct our new circle equation based on what we know now. The radius stayed the same, so we're going to have something equals 49. And then we have our x part also stayed the same because all of them still lie on the same line. It only moved up, so it only changed the y value. So our x part still stayed the same. And then we have our change in the y. So since it's subtracting -10, we have y plus 10 squared. And that's why our answer was B. Okay, so the y in this case stood for the variable. So you know how in linear equations, we always have y equals like mx plus b. These two are just variables. That means that they can basically take on any value. Well, the x can take on any value, and then the y is just based off of that. So that's how we draw our graph. In our case, the y minus y1 part and the x minus x1 part, whenever I write x and y, that's going to be the variables for the x and the y. So we can plug in any point, and if we have any point x and if we have a point x comma y, let's just have our radius over here. If we have a point x comma y, to test if it lies on the circle, then we plug it into our x here and our y here. But the x1 and the y1 are fixed because we already know the center of this circle. Okay? Does that make sense? Yeah. So x1 and y1 are the center, and the x and the y are any point. Well, the x and the y have to fit this equation in order to make it a point on the circle. But to test, you can basically plug in any point. Okay. Are there any more specific topics that you guys want to talk about? Let me check in our practice to see if there are any more harder problems. I can also, okay, do you guys want to try the examples on the slides? Because we did not go over all of those last time, but they're all going to be about geometry and radians and stuff like that. Okay. So we can do that. I skipped over many problems yesterday because we were running out of time, but we can go more in detail. Okay. I just need to wait for it to load. Okay, it loaded. Okay, we did this really quickly. Okay, so there were many problems, I think, on the histograms and the box plot that we did not finish. So, okay, we actually went over all of it. Okay, so we can continue with this one. We did not go over this one. So I'll give you 2 minutes, and if you have the answer, you can put it in the chat for me. Okay. Did anyone figure out the answer? Okay. I will go over it now. Okay, so let's go over number 3 first. Okay, so we're trying to find the length of this minor arc AB. And from before we learned that the length of our arc is also the same as, the length of our arc AB over our total arc of the circle, which would be 2 pi. Is the same as our, whoopsies. Okay, this is the angle of AOB, okay. So, angle AOB over our total angle, which is going to be 2 pi, is the same as our arc AB over the circumference of the circle, okay? I don't know how to denote that, but we do know that the circumference of the circle, this length over here, is 2 pi r. That is the circumference of the circle. So since the radius, or r, is 36, then we know that the circumference of the circle is 72 pi. Okay? So since we know since we already have this, and we also have angle AOB, so this is 5 pi over 12, then we can figure out the length of our arc AB. So we have 5 pi over 5 pi over 12 divided by 2 pi times 72 pi is what we want. Okay? And easy ways to do this, don't simplify this already. You can easily cancel factors out. So like if you see a pi that you're multiplying by and a pi that you're dividing by, you can just cancel them out already like that. Don't try to solve everything at once, because that is much harder and it takes a lot more work. We also see that 72 divided by 2, we know what that is. It's 36. So we can cancel out the 72 to make it a 36, and we can cancel out the 2. And then we have 36 divided by 12 is 3. So we cancel that out again, and we just cancel out our 12 in the denominator. Okay, so now we have 5 pi times 3. So that it gets us our 15 pi here. Okay. Okay, so that is how we can do it. Okay. And also, we had our formula from before. Okay, so the radius times the theta in radians also gets us the length of our arc. And that's why radians are so much easier to do things with. Okay, so now if we're trying to find the area of the sector AOB, we also have our formula from before, which is just 1/2 radius squared times theta. But we can also derive this, which I like doing because it's more intuitive. So how can we get 1/2 of r squared theta? Well, we know that the area of our sector AOB, I will say that's the area, over the area of our total circle. So we know that the total circle is has an area of 36 squared times pi. This is equal to our angle over the total angle. So we have 5 pi over 12 over our total angle, which is 2 pi. Okay. If we were going to write this in a general form, we would say that a sector AOB over r squared pi is equal to our angle theta over 2 pi. So our sector AOB is just 1/2 times the r squared pi times theta over pi. I moved the 2 in the front, if you can see it over here. So then that's how we can get our 1/2 r squared theta. But we can also just do it the way on our bottom, at the bottom. So that means that you can just get it immediately and we don't need to memorize formulas like that. Although they are helpful to memorize. Okay, so now we have that AOB over here is equal to, we can cancel out the pi's because we don't need it. One's on the top, one's on the bottom, we cancel it out. I would like to write this 36 squared as 36 times 36 because I do not want to calculate what 36 squared is equal to. That takes a lot more work. So we have 36 times 36 times 5 over 12 times 1/2, basically. Okay, so we have a 36. We can cross it out to make it become a 3 because we divide it by 12. And then for the other side, we have that this is 18. And we divide by 2. Okay, so now we have 18 times 3 times 5. Okay, and this should get you to our 270 pi. Oh, I forgot the pi. We multiply by a pi from here. Okay. So everybody good on that? Okay. We went over these formulas. Okay, I think these ones are a good practice because on the SAT they probably are going to give you a lot of geometry questions because that's all that's basically covered in the additional topic section. So you can take a look. I'll explain these very quickly now, and you can apply these for the next few problems. Okay. So, first of all, if we know this angle AOB, this is called an inscribed angle. It is, so if we draw any circle and we have our center, we take it and a portion of this circle. So this is our first angle, theta. If we draw like any line to a point on a circle, or we connect it to any point on the circle, this section is going to have an angle of theta over 2. Okay, so that is very helpful. So sometimes when you need to angle chase, which is just like, if you don't know what the term means, it's just finding a bunch of angles so that you can kind of find a pattern, or maybe you want to just find an angle, and so it's easier to angle chase. Then you can just use that because a lot of the hard geometry problems use circles. Okay. Our next one is about tangents. So these are tangents. That means that when you draw this line, it only intersects at that one point, and that one point creates a 90-degree angle. It's perpendicular to our, to this line between this center and the outside point. So that should create a 90-degree angle. And then we know, since a quadrilateral, the sum of the angles in a quadrilateral are always 360 degrees. It's made up of 2 triangles, and each one of them has a sum of 180 degrees. So we know that the sum of these 2 angles is 360 minus 90 minus 90. Okay? Because these 2 angles over here are 90. So that is just 180 degrees. So we know that this angle plus this angle is 180 degrees. Okay, for our next one, this is a very, very common one. So if we have these angles like this, this angle is equal to this angle. And the reason for that is just because of our first formula over here. They are both inscribed in the same arc. So one arc corresponds to one section of the circle. The length of that arc determines the angle right here. So that means that each of the ones extending outwards like this and this are half of that angle in the center. So that means that those two angles are equal. Okay, if we have a diameter and we draw any line like this that connects to a point on the outside, that is 90 degrees. So you always create a right triangle by doing this. This is very important. Okay. And now we have power of a point. This is one form of power of the point. It is derived by taking these two triangles here. And since we know that these inside angles are the same and these two angles are the same from this formula, we know that these two are similar triangles. Okay, so since these two are similar triangles, we have that B over D is equal to C over A. So then we have our AB equals CD. I will talk to you about the other form of power of the point, although you probably don't need to use it. If we have an angle or two lines drawn outside of it that meet at one point, we have that, I will call this A, B, C, D. We have that A times A plus B. So this times that is equal to this times that. Okay, and this is also done by taking a similar triangle. So if we have this section over here and this section over here, we know that this angle is equal to this angle. We talked about this before because it's actually just this formula here. Okay. Because we know that that first angle is equal to the second angle and they also share this angle here, we know that A over C plus D is equal to the C over A plus B. So that gets us our A times A plus B is equal to our C times C plus D. And so you can just memorize these, but you won't look at them. Well, they're probably not going to really appear on the SAT. It would be helpful to know though, because it can help you solve some problems. Okay, we also have alpha plus beta equals 180 degrees in this quadrilateral. This is a special type of quadrilateral. It's called a cyclic quadrilateral because it is inscribed in a circle. And for cyclic quadrilaterals, we know that the sum of the opposite angles add up to 180 degrees. And so that means that this angle on the outside, which is 180 degrees minus this beta, would just be the same as alpha. Okay, so those are the main formulas you need to know. And let's try some practice. So once you get these answers, I can give you a little bit more time on these because these may be a little harder. You can tell it to me in the chat. Okay. So far I got one answer for number 1. Did anybody else finish it? Okay. I will go over it in a minute then. If you have already finished, you can move on to the second problem. Okay, I will start going over the first problem now. Okay, so the trick to this is to always, if you see the word tangent, oops, I don't have my mark. Okay, if you see the word tangent, mark in the tangents. So that's also a hint for this problem. But it says that these two lines are tangent to the circle. So we know that all tangents are 90 degrees, are perpendicular. Well, that point to the center would be perpendicular to each of those lines. So always mark that in. That is very helpful. And we also know that the radius of the circle is 12. Oops. Okay. We also know that the radius of the circle is 12 here. Okay, so remember this kind of formula that we had from before. If we have two tangents at the angles over here, we know that the sum of the other angles would be 180 degrees. So I'll call this O. That means that POR plus 60 degrees is equal to 180 degrees. Okay, so that means that our POR is equal to 120 degrees. I'm doing this in degrees because the 60 degrees was in degrees. Okay, so now since we know that this is 120 degrees, we can apply our sector kind of formula. Okay, so that was just a list of things that are equal to the angle over the total angle of the circle. So in this case, this would be 120 over 360 is also equal to the length of our PR. Oh, that was not a P. Of our PR over our circumference of the circle. And since our radius was 12, we know that our circumference of the circle is 2 times 12 times pi. So we have 24 pi. Okay, so now we have that PR. We can cross this out. This is 1 over 3. So PR, oops, okay. PR is equal to 24 pi over 3. Sometimes it doesn't draw. Okay, so this is equal to our 8 pi. So we get C. Okay, so we can go on to our second problem. This one is also kind of hard. There are many methods, but some are easier than others, I will just say. Okay, I will let you do this for 3 to 5 minutes. Okay, did anybody finish it yet? Or got an answer? Oh, whoops. I forgot to do this. Okay. So, for this problem, we have two ways. I'll say both methods are like pretty fast, but there is one that is faster than another one. Okay, so I'll do the faster one first so you can kind of see. Okay, so it says that there's this right triangle with B is 90 degrees. And we see the word tangent again. Okay, that means that we should draw in the center of our circle and the three tangents. So those are all 90 degrees. Okay, and then we also know that the length of AB is 10 and the length of BC is 24. So then we're trying to find the radius of this circle. Okay, so our first way, we look closer and we can look at each section specifically. So we have kind of like split it into three sections. Let's look at each section specifically. Okay, well, we see like this is the most common shape that like we saw on one of the formulas that we saw. Okay? On this formula, we saw that, well, this angle plus this angle was like 180 degrees, right? And we also know that we can kind of split it into these two triangles. Okay, so actually, oh, I did not tell you. Wait, we did tell. Okay. Okay, the formula was that we know that this side length plus this side, well, is equal to this side length. Okay, but I was going to go into how we know that. Okay, so how we know that, you split it into two triangles. Okay, we know that this side is equal to this side. And we also know that this length is shared. And since we also know that this is 90 degrees, that means we can get all three sides, since we already know this side and this side are the same. So the third side definitely has to be the same. But okay, so our formula got that this side has to equal this side. Okay, I forgot we should call this radius r. Okay, I always like r. And this r is gotten from here. Okay, so that means that this side, right over here, is equal to 24 minus r. Okay, and that is the same as this side. Okay, we also have that this side is equal to this side, basically. So we have that this is 10 minus r. And this is also 10 minus r. And if you notice, this is a right triangle. So we can get the length of the hypotenuse by using the Pythagorean theorem. Okay, and I like memorizing this stuff because I do like math competitions and stuff, but we can basically find that this is a 5, 12, 13 triangle if we divide both of these by 2. So that means the length of the hypotenuse is 26. And if you try doing the Pythagorean theorem, you would get that last side is 26. Okay, so that means that 10 minus r plus 24 minus r. Oh, is equal to 26. Okay? So that means that, let me erase some of this stuff. Okay, so that means that 34 minus 2r is equal to 26. Okay, so I'll get 2r is equal to 8, so r equals 4. Okay. Now we can try the other way. So the other way, still we draw these tangents because they are very helpful. And they are a condition given in the problem. If the problem gives you a condition, you are most likely going to use it. Okay, so now we have drawn in these. And we don't really like these quadrilaterals, so we start to draw in triangles, actually. Okay, and okay, so now we can kind of see something that is very helpful. Okay, I have changed my pen. Okay, so now we know and see 3 triangle areas. Okay, so that is one triangle area. That is another triangle area. And our third one is right here. Okay, so we know that the area of this triangle is basically covered by these 3 triangles. Okay, and okay, let's make that radius r again. Okay, so now we know that the area of this triangle is the sum of these 3 areas, and by using the Pythagorean theorem, we know that this is 26 again. So we know that 24 times r over 2 plus 10 times r over 2 plus 26 times r over 2, because those are the areas of our triangles here. So this should equal the area of our entire triangle, which is 10 times 24 over 2. Okay, so now if we add all these together, we get 60r over 2 is equal to, let me write this in another area. Okay, is equal to 240 over 2. So then we have r equals 4 again. So that is another way, but it involves more calculations because we know that, we need to get, again, that AC equals 26, and then we have to find the area of the triangle too. Okay, so let's go on to our next problem. So we were talking about complex numbers. I kind of talked about the first one. You can try the second one now. I will give you 3 minutes. Okay, did anybody finish number 2? Or do you need more time? Okay, so I did not see anybody send me an answer, but I'll go over it anyways. Okay, so we have that, well, we know what I is. I is always square root of -1 if we see it in a problem. That's why we don't really see the variable I that much. Okay, so we are trying to find which of the following is equal to I to the 126. Well, I think there might be a pattern in this. Otherwise, how would we find it, right? Okay, so we have I first, okay? And then afterwards, we have I squared. And then I squared, we know, is -1. Afterwards, we have I cubed. And that's just -1 times I, right? So that is -I. Okay. Our next one is I to the 4th, and that gets us to -I times I. So that is just 1. Wow, we got back to 1. And so if we keep on doing that, if we do it again, we're going to get I again. And then after that, we will get -1, and then -I, and then 1. So this repeats in a pattern of 4. So we can use that I to the 4th is equal to 1 and try to find, like, what is the closest power of I to the 4th to I to the 126? Okay? Well, we know that 124 divides 4. So this is basically, oopsies, I to the 4th, all to the 31 times I squared, because we still had, oh my gosh, my 2 is not very good. Okay, that is a 2. Okay, because right from here, we have I to the 124. My computer is very laggy, so this pen is not working very well. Okay, so this is I to the 124, and then by powers of exponents, we have that I to the 124 times I squared is I to the 126, and that is what we want. And so, since 1 to the power of anything is always 1, so we have, this is 1 times I squared is equal to I to the 126. Okay, and this is just -1. Okay, perfect. Let us go on to example number 3. Okay, so you can try this. Can you see the bottom here or no? Is it also cut off for you? Okay, oh, but if I go into the big screen, you will see the answer. Okay, I will move it up. Let me reshare. If the computer loads. I don't know why. My internet is slower today. Okay, you know what? I think it's kind of frozen. So, I will just tell you that the bottom answer should be 1/2 plus root 2 over 2. Oh, wait, it worked. Okay. The bottom answer should be 1/2 plus root 2 over 2i. And it came back again. Okay. I will rewrite it. Okay. I got one answer so far. But we can go over this. Okay, so from our rational root theorem, this is like our first line of thinking, right? From our rational root theorem, if there was a solution that was rational, we can check it. So that means that it can either be, the numerator has to be a factor of 3, or, and the denominator has to be a factor of 1 because the coefficient of x cubed is 1. So that means that we only test 4 different values, right? We have 1, we have 3, we have -1, we have -3. Oopsies. Okay. But if we test each of these, we don't actually get 0 because from our factor theorem, if one of these was a factor of x cubed minus 2x squared plus 3x. If like our factor that has a root of -3 would be x plus 3. If that was a factor of x cubed minus 2x squared plus 3x, that means that x cubed minus 2x squared plus 3x, if we plug in x equals -3 in there, then it should get us 0, because the remainder, when it's divided by x plus 3, it should be 0. Okay, but if we test these, they don't work. So we look for a different solution. Okay, if we look closely, we see that all of them have a factor of x. So that's much easier, okay? So, and you might have just already jumped to this conclusion, but I was just modeling like what our thinking might be. Okay, so if we have, well, we see that all of these have a factor of x, so we can just factor out an x. We know that 0 is automatically a solution. So that means that this is x squared minus 2x. My 2's always look like straight lines. Okay, 2x plus 3 equals 0. Oh. Okay. Okay. So, but we see that 0 is not one of our solutions. Not one of our answer choices. So we can just disregard this 0. It has to be one of the factors of x squared minus 2x plus 3. Okay, and by doing that, we can just use the quadratic formula. Okay, so by using the quadratic formula, we have that this is 2 plus or minus square root of 2 squared minus 4 times 3. Oh my gosh. Okay, minus 3 over 2. Okay, and 4, this 2 squared minus 4 times 3 is equal to -8. So we have 2 plus or minus square root of -8 over 2. And this is basically, if we write it with I, this is basically 2 plus or minus I times 2 root 2, because square root, right, is 2 root 2. I think I might be lagging a little bit because my computer is lagging. Okay. So this is equal to 2 plus or minus 2I root 2, because we know that I equals square root of -1. So we can just do that. It's equal to I times root 8. Okay. Okay, so we know that this whole equation, since square root of -8 is equal to I times root 8, yes, I times root 8, and root 8 is 2 square root of 2, because we can just factor 2 squared out. Okay, then we can simplify this, and this gets us to 1 plus or minus I root 2, and these are both roots. Okay, these are both roots of this polynomial. But we only see one of them here, and that just gets us C. So that would be our answer. Okay. let's move on to the next one. Okay. Okay, so now we move on to data interpretation. Okay, so I know one of you wanted some more practice with graphs. So here's some more practice with graphs. Okay, I'll give you a few minutes and you can try it. Okay, and if you were a little confused, when it's asking for the median score on test 1 and 2, it means that you should get the median score for test 1, and then you should get a separate median score for test 2. Okay. Okay. Let's go over these now. Okay. So remember remember that the median is the middle, the very middle score. So if we're lining this from the smallest score to the largest score, we're going to find the score that is in the very middle. Okay, and it says that there are 10 students. So that means we need to take the average of the 5th and the 6th student, because those two are the students in the middle. So if we're looking at test 1, right? It's already like set up for us so that we're going from least to greatest. So we have one student here. This is the 2nd student. This is the 3rd. This is the 4th. This is the 5th. And this is the 6th. Okay, so that means the median for this one B is at 70 because this is 80 and this is 60. That means that the median score between, well, for test 1 would be 65. Okay. Okay, so we have number 1. Oh, oops. Okay. I already showed the answer for number 2. Okay, but the score for the second one, since we count, it's the same when counting from the largest to the smallest or the smallest to the largest. We just take the 5th and the 6th one. The 5th and 6th ones because they are in the middle. So that means that we can go from here. So like 1, 2, 3, 4, 5, and 6. So these two are the ones in the middle where we can just go 1, 2, 3, 4, 5, 6. Those are still the ones in the middle, and they have a score of 70. So the median is 70. The average of them is 70 because they both have the same score. Okay, so now we can do the average arithmetic mean on test 1. Okay, so for test 1, we only need to look at this x-axis, basically. Because we are finding the arithmetic mean, we just need to find 30 over here for an A. Oh, maybe I should type this out. This is not working. Okay. 30 for A plus the 40 for the second point afterwards, right here. And then after that, there are two 50s. So we add two 50s. And then we add on a 60. And then we add on 70. And then we add on 3 80s. And then we add on 100. And there are 10 students. So we divide this whole thing by 10. Okay. And then, since you can use a calculator, you can just add it all up and divide. Or sometimes I just divide 10 on all of them. So I have 3 plus 4 plus 2 times 5 is 10, plus 6 plus 7 plus 8 times 3 is 24, plus 10. Okay? Now we add this, and then I like making groups of 10. So like I see the 24 and the 6, I automatically know that that's 30. I see two 10s, that gives me 20. I see the 3 and the 7, so that gives me a 10. And I have the last one, which is a 4. Okay, so this gets us 64. And that is our answer for the second one. Okay. Okay, we have some more practice. This is kind of like the one that we did on the test. You can try it. this should have been pretty fast. Because again, we see a line of best fit, right? Which one is closest to the average arithmetic mean? It's basically the slope of this line, because it's the cost over the pounds for each one, cost per pound. So then we just have 6 divided by 8, because it always meets at this corner over here. That would get us 3 over 4, or 0.75. And out of these answers, sometimes it likes to trick us like that, because they don't give us the actual answer, they give us the closest one, which is 0.73. Okay. Okay. Okay, so I think we basically finished all the problems now. Do you guys have any more questions for me? We only have 4 minutes left too. Okay, so you can, you're still going to be shared in the Google Drive afterwards, so you can always look back to these slides, and you can also try the many practice tests. The solutions are already on there, and there are also many books for you to prepare for, and then there are also other study materials on that Google Drive. Okay, so, okay, the SAT is a very contradictory topic, I would say. So many good students are trying to aim really high, between 1500s and 1600, which is the highest score you can get. And then there's also another thing, which is the PSAT, and that is kind of just a mini kind of test that's kind of mocking, or just a smaller kind of SAT version. And you can also try that. I did it last year, so that one's a kind of mock-up that you can try. And then you can also take the PSAT in the 11th grade, and you can try to go for national merit if you get a really high score. And it also helps you prepare for the SAT. You can prepare for both at the same time, and the reading and the writing, they're both out of 400, so you kind of have to split up the reading and the writing, and get a good score on both. For the math, since it's already 2 sections, calculator, no calculator section is already out of 800, and so many students get 800s on it. So you can try to aim for that. And there's also a kind of leeway, so maybe you get one question wrong. Sometimes, for some years, if the questions are really hard, you still get an 800. Okay. We also have some questions on the solids, but that's just basically using the formulas. Oh, we can actually try this last problem. If you want to go, you can go.
Thank you. Goodbye.
Okay, bye. Okay, so this last problem is a little bit harder, so that's why I picked it. So you can try this for a few minutes and I can go over it afterwards. I know I came a little bit late, so I'm kind of making up for it. It actually might not load. Yes, okay. You can listen to the solution. I just need to make sure that this can load. So I will stop the share for a second, and once my computer unfreezes, okay. Tell me if you can see the screen, or tell me if you can see the problem, even if I go out. Like, oh, it's still not loading. Okay, tell me if you can still read that. Oh, I reloaded the page. Okay. So this problem is about a cylinder and a cone. And they both have the same height, okay? Height is the same. Okay, but the radii are different. So this is R1 and this is R2. And we also know that the volumes of these two shapes, well, these two solids are the same too. So we're trying to find the ratio of R2 over R1. And to do that, we know, well, okay, it kind of loaded. Okay. Okay, it doesn't seem like it's going to load anymore. Okay, so we can just use the volume of a cylinder and the volume of a cone to kind of compute this. So we have that R1 squared times pi times h, because that is the volume of a cylinder, is equal to R2 squared times pi times h over 3, because this is the volume of a cone. Okay, so then we can cancel out the pi times the h on both sides, and so we have that R2 squared over R1 squared is 3. Okay, so since that's 3, we know that, okay, this is 3. It's so laggy. Okay, this is 3. Okay, so since this is 3, we can do the square root of both sides because we know that R2 and R1 are both positive. These can't be negative. They're the radii of different solids. So that means we can just square root it because we know that square root of 3 is positive. Okay, so then we can get that R2 over R1 is square root of 3. Okay, but for this one, you needed to know the volume of a cone and set them equal to each other. So more algebra. Okay, so I guess that's it for today. And if you have any questions on any math problems, you can email me. I have my email in the chat. I will put in the chat. But if you have any questions, you can email me. And thank you for coming to the seminar. I hope you learned some things. Okay, bye. See you.
Thank you, Athena.
Okay, bye.